It's all about a lag lead compensator. It's a transfer function. We start with the lead and lag individually, and then we combine. Why? Because it's a cascade of a lead and lag compensators individually. Talking about the transfer function, the closed loop transfer function G of S of a lead compensator, we have S plus 1 by tau by S plus 1 by alpha into tau, and the condition is during the design for lead compensator itself we come across that alpha is less than 1. Alright, for supposing alpha less than 1, in the sense let it be 0.5, plugging in this value over here itself, it's a alpha being 0.5 here, 0.5, and 1 upon 0.5, that's a S plus 1 by tau, the numerator as it is, S plus 1 by 0.5, it's 2 into 1 upon tau. Guys, from here what it says, this factor is trying to say something. 0, the numerator 0, S is equal to minus 1 upon tau, and the pole is at S is equal to minus 2 times 1 upon tau, 1 times 1 upon tau and minus 2 times. Like if we plot this 0 and plot existence in a S plane, supposing it's minus 1 times tau, minus 2 times 1 upon tau, like that. Alright, for supposing, and minus 3 times 1 upon tau, like that. We have a 0 at 1 times over here. This is the 0, and this is the pole. Minus 2 times 1 upon tau, we have a pole over here, and this is the pole 0 combination for a lead network. And on the other half, looking at the transfer function of a lag network, we also have S plus 1 by tau, S plus 1 by beta tau, and during the design procedure, discussions, we come across for lag where beta value being greater than 1, for supposing beta is equal to 2, greater than 1, that beta being 2, what do we have? S plus 1 upon tau in the numerator as it is, S plus 1 by beta, you have assuming that to be 2 tau, and S plus 1 by tau in the numerator as it is, S plus 1 upon 2, it's a 0.5 into 1 upon tau, and locating the pole and 0 in the S plane, where do we have? This is supposing these are S plane, and minus 1 times 1 upon tau, minus 2 times 1 upon tau, something like that. We have a 0 at 1 time 1 upon tau, we have a 0 over here, and pole is at 0.5 times 1 upon tau. It's in between 0 to 1, so it's the pole is over here. That's the pole 0 combination for a lag network. Lag network for beta greater than 1, and this for the lead, and the pole 0 combination for a lag and lead network is the combination of this one. How it is, like we have a S plane and pair of pole and 0 from the lead network, which is over here and here, and pair of a pole and 0 combination from lag network, which is like this, and over here. Now this finishes the pole 0 location for a lag and lead network. All right, and it's the cascade, the lag lead compensators, a cascade of lag and lead networks individually. And so now this gives like the transfer function over here. We need to focus on the transfer function over these two over here. All right, for a lead network, we have 1 upon alpha tau, this one, 0, and a pole location for lead network, into, because it's a cascade, into S plus 1 upon tau by S plus 1 upon beta tau. It's another 0, another pole from the lead network and from the lag network. All right, so tau, no, it's like a bit confusing, so they have given a name tau 1 over here and tau 1 over here, tau 2 and tau 2. Guys, this will be the transfer function of a lag and lead network, which is a cascade combination of these two individual compensators, but this design will be tedious. Alright, we cannot have the beta and alpha separately. The complete transfer function should be in terms of completely alpha over here and alpha over here, or else beta and also beta over here. So in that case, we will have to consider electrical lag and lead network, and we have to establish a relationship between alpha and beta, and then that can be plugged in over here. Remember, once again, the entire transfer function should be in terms of beta. Okay, it's beta. Here also we need to have a beta for the design to be easier. And if we want to have a alpha over here, even this should be alpha. In that sense, we need to establish a relationship between alpha and beta, and plugging it back again in this expression, and that will be the final transfer function for a lag and lead compensator. And for that, to carry out the analysis, let's consider a cascade combination of electrical network. In the sense, it will be like this. The arrangement will be like this: a resistor and a capacitor in parallel, and another resistor and capacitor in series, giving the names R1, C1, R2, C2. We have that V in over here and V naught over here. Guys, according to potential, once again, simplifying this one, let this combination be Z1, impedance Z1, and let this be Z2. Alright. So what is Z1? Z1 is a parallel combination of R1 parallel to XC1. That will be resulting in, guys, you may be having an idea on this one, R1 by 1 plus S R1 C1, the parallel combination of this one. And the series combination Z2 is a series combination of R2 plus XC2, which is equal to R2 plus 1 by SC2. Hope you have an idea how did we get that, from where did we get this S from. XC, which is equal to 1 by J omega C, and J omega is considered to be S, and so that reduces to SC. And if we have, it's a first 2, it's a 2, that's it. I made use of this one. Alright, so simplifying this one, it's like, what do we have in the denominator? S C2 and 1 plus S R2 C2, which is our Z2. And according to potential divider rule, we have V naught can be written in terms of Vi, as V naught is equal to the opposite impedance Z2 into Vin upon the total impedances Z1 plus Z2. Alright, in that case, we have, guys, okay, let me make use of this place. Alright, V naught, that will be equal to, what is that, Z2? Z2 we have 1 plus S R2 C2, and in the denominator we have S C2, and Z1 plus Z2. Z1 we have R1 by 1 plus S R1 C1 plus Z2 once again. What is that, Z2? 1 plus S R2 C2 upon SC2 into Vn, and we are in search of that transfer function. So bringing that Vn over this side, we have Vn, which is the transfer function which we are in search of. And going ahead, simplifying this equation for the transfer function, which one? Just now, which we have written over this side, guys, over here, and 1 plus S R2 C2 upon S C2 in the numerator as it is, some modification in the denominator. Why? Because we have two factors over here, and 1 plus S R1 C1 into S C2 from these two, simplifying these two, and cross multiplying, what do we have? S R1 C2, which is this, plus these two factors. All right, so 1 plus S R2 C2 into, what do we have? 1 plus S R1 C1. All right, so this is the one, guys. If I'm not wrong, these two gets cancelled here. SC2 gets cancelled, and this goes up, this flips up, isn't it? In the sense, we have 1 plus S R2 C2, more precisely, all right. Why? Because let me tell you, 1 plus this goes up, S R1 C1, this one, into 1 plus S R2 C2. We're done with the numerator part, and in the denominator, what do we have? 1 S R1 C2 plus, guys, well, let's multiply over here. All right, let's simplify this one. 1 into entire thing, so that repeats as it is. 1 plus S R1 C1. 1 into this one. This into this plus S R2 C2 plus this into this. For this we have S as it is plus S into S. We have from this term we have S squared to S into S, and also the entire one, R1 R2 C1 and C2. Did we miss something? No. All right, this one. And what modification can be done? No modification, just rearranging that one. All right, 1 plus S R1 C1 as it is, and 1 plus S R2 C2 also as it is. Guys, in an order, like quadratic expression in an order, S square into R1 R2 C1 C2 plus S from here. We are done with this one. All right, let me mark it. S from here, S from here, S from here, and S from here. What do we have? Inside the braces we have R1 C1 plus R2 C2 plus R1 C2. All right, close the braces. You're done with this plus 1 is a transfer function. All right, and you're almost there. We are done with the picture. We don't need this anymore. So let me make use of this place to explain what is going to happen, as there is final comparison with this one. And I forgot to tell you in the beginning itself. Let's do some simplification over for this one. We need this one. We need this transfer function, this one as it is. All right, from the electrical network, and a small simplification over here. GC closed loop transfer function of a lead and lag network combined. S plus 1 upon tau 1, S plus 1 upon tau 2 completely, S plus 1 upon alpha tau 1 into S plus 1 upon beta tau 1. What did I do? I told we have to do some modification, isn't it? I wrote as it is. I'm sorry. This into this, S square plus this into this, S into 1 by beta tau 2 plus this into this, S into 1 plus alpha tau 1 plus, and from here 1 by alpha beta, this into this, alpha beta tau 1 and tau 2. All right, the transfer function cascaded, and this from the electrical network, rewriting it over here again. Okay, so we had V naught by B in the transfer function of a electrical network. What is that? 1 plus S R1 C1, 1 plus S R1 C1 as it is, into 1 plus S R2 C2 as it is. Guys, from here, taking out this entire term as common from all the terms, from this and from this and from here also, taking out R1 R2 C1 C2 as common. All right, so in the sense, if we take out R1 R2 C1 C2 as common from here, we will be left with only S square from here, and plus S from the first factor. R1 and R1 C1 has come out, so we will be left with 1 upon R2 C2. Multiplying this, we will have this one only, and from the second, 1 by R2 C2 is already taken out, so we have R1 C1 plus, guys, R1 C2 is already taken out, so we have 1 upon R2 C1 and close the braces for S term. Close the braces for only for S term. This one we have, this one, see, plus 1 upon continuation here. From here also taking out R1 R2 C1 C2 as common. What do we have? 1 upon R1 R2 C1 C2, and multiplying this one, R1 R2 in the numerator and denominator gets cancelled, and we will go back to this one again. That's what. All right. And also taking out R1 C1 from here in this factor. All right, here from this factor, taking out R1 C1 as common, right? So if I take out here itself, let me do the modification. If I take out R1 C1 as common from here and here, so only S over there. All right, so we'll have only S plus 1 upon R1 and C, R1 and C1. All right, and also R2 C2 as common from here and here. Take it out. We have R2 and C2. Then we don't have this. This small modification will be S plus 1 by R2 C2. Why? Because we have taken R2 C2 as common. All right, and in this ratio, this gets cancelled with this one. We don't have that anymore. We don't have this anymore. Why? Because we have that same factor over here. Now comparing this expression with this one, see, it's very much in the sense we can take out S as common from here and here, so this can be put it in single bracket like this. All right, this factor, this and this, S square plus S into something plus constant, and also that a constant, so it's very much, so this can be compared. When compared, this will be this, which gives us S over here. This is this factor, in the sense 1 upon tau 1 is equal to 1 upon R1 C1, which implies tau 1 is equal to R1 C1. A very important result. All right, and also this is this, in the sense 1 upon tau 2 will be R1 upon R2 C2, which implies tau 2 will be equal to R2 C2. Another important relation, which gives us the final transfer function for the lag-lead network. And also this is equal to this, and also this is equal to this. All right, so 1 upon alpha beta tau 1 tau 2 equal to this one, 1 upon R1 R2 C1 and C2, and which implies alpha beta tau 1 tau 2 equal to R1 R2 C1 and C2. And guys, from the above results, what do we have? R1 C1 is equal to T1 tau 1, R2 C2 is equal to tau 2 here from the comparison itself, in the sense alpha beta tau 1 tau 2 is equal to, and this combination, this R1 C1 can be plugged in with tau 1, and this combination R2 C2 combination can be plugged in with tau 2. All right, so alpha beta will be equal to tau 1 tau 2 by tau 1 tau 2, which is equal to 1. What did we get? What did we have? The final conclusion says alpha beta equal to 1, or else beta will be equal to 1 upon alpha. So making use of this very relationship between alpha and beta, this can be modified. Come back to the first, that transfer function for lag network, the cascaded combination. Looking at this one, guys, here if you want to, like, okay, let me go for complete beta. We have beta and 1 upon alpha here, 1 upon alpha can be plugged in with beta. So here in the sense complete 1 upon alpha, that can be written, that can be plugged in with beta by tau 1. Now this is the transfer function, the complete transfer function of a lag lead network. That's it.